For as long as humans have gazed at the night sky, we have asked the same impossible question. How did all of this begin? Every star, every galaxy, every atom in your body traces its history back nearly 14 billion years to a moment we call the Big Bang. According to modern cosmology, this was the event that marked the birth of our universe, when space expanded, energy emerged, and the cosmos began its long journey toward complexity. But this raises a deeper, more unsettling question. What came before? Was there truly nothing, or is that word hiding something we don't yet understand? The Big Bang is often imagined as an explosion in space, but that picture is misleading. It wasn't matter flying outward into pre-existing emptiness. Instead, space itself began expanding everywhere at once. Even more astonishing, time may have begun at that moment too. In Einstein's theory of general relativity, space and time are woven together into a single fabric, space-time. When we mathematically rewind the expansion of the universe, space-time itself shrinks down to a limit where our equations stop working. That limit is what physicists call a singularity. At that point, density becomes infinite, temperatures soar beyond comprehension, and our laws of physics break down completely. If time itself emerges from this boundary, then asking before the Big Bang may be like asking what lies north of the North Pole. There may simply be no before. But science rarely stops at the first answer. Although we can't see the Big Bang directly, the universe has left behind a remarkable fossil, the cosmic microwave background. This faint radiation fills all of space and comes from a time when the universe was only about 380,000 years old, an infant by cosmic standards. Before that moment, the universe was so hot and dense that light couldn't travel freely. Space was a glowing fog. When the universe cooled enough for atoms to form, that fog cleared, and light escaped for the first time. That ancient light still surrounds us today, stretched by billions of years of expansion into microwave wavelengths. It is the oldest picture we will ever have of the universe. Tiny variations within this radiation, regions slightly warmer or cooler than others, mark the seeds of everything that followed. Galaxies, clusters, and the vast cosmic web all grew from these minute irregularities. By studying this pattern, cosmologists have learned something profoundly strange. Everything we can see, stars, planets, gas, dust, accounts for only a small fraction of what exists. Roughly 95% of the universe is made of things we cannot directly observe. About a quarter is dark matter, an invisible substance that provides the gravitational backbone for galaxies. Without it, cosmic structures wouldn't have formed fast enough to match what we observe. Even more mysterious is dark energy, which makes up most of the universe and is driving space itself to expand faster and faster. This discovery came in the late 1990s, when astronomers realized that the expansion of the universe isn't slowing down, it's accelerating. Something is pushing everything apart, and no one knows what it truly is. Recent observations suggest that this mysterious force may not even be constant. If dark energy changes over time, then the long-term fate of the universe becomes an open question. Endless expansion is no longer guaranteed. And if the future is uncertain, so too might be the past. After the cosmic background light faded, the universe entered a long period known as the Dark Ages. There were no stars, no galaxies, only slowly cooling gas drifting through growing darkness. Hundreds of millions of years later, gravity finally gathered matter tightly enough to ignite the first stars. These earliest stars were enormous and short-lived, blazing intensely before collapsing in violent deaths. Their light ended the Dark Ages and transformed the universe forever, forging the first heavy elements and setting the stage for galaxies. Today, powerful instruments like the James Webb Space Telescope allow us to glimpse this distant era. By capturing faint infrared light from extraordinarily early galaxies, astronomers are seeing cosmic history closer to its beginning than ever before. And what they're finding is surprising. Galaxies appear earlier, brighter, and more massive than theories predicted. The universe seems to have organized itself with astonishing speed. Once again, reality is nudging us beyond established ideas. On the largest scales, the universe is expected to look smooth and uniform. This idea, called the cosmological principle, is a foundation of modern cosmology. Yet astronomers have begun discovering immense structures that challenge this assumption: colossal arcs, walls, and patterns of galaxies stretching across billions of light years. Some of these structures are so vast that they strain the limits of what standard models allow to form. Are they rare coincidences, statistical flukes, or are they clues that the early universe behaved differently than we thought? Some researchers propose exotic explanations, including relics of processes from the universe's earliest moments, or even remnants from something older than the Big Bang itself. What if the Big Bang wasn't the start of everything? One possibility is that the universe didn't begin in a singular creation event, but instead emerged from a previous cosmic phase. In some models of quantum gravity, the universe undergoes cycles. A previous universe could have collapsed under gravity, only to rebound in a big bounce, giving rise to our expanding cosmos. In such scenarios, time never truly began. It simply passed through a transformation. Another radical idea suggests that the universe experiences multiple bursts of creation over its history rather than just one. Instead of relying on dark matter and dark energy, these models invoke brief, rare events that inject energy into the cosmos, altering expansion and structure formation. While speculative, these theories exist for one reason: the universe keeps presenting puzzles that resist simple answers. There is also a more subtle possibility. Perhaps the universe doesn't need a beginning at all. Some models describe a cosmos that is eternal, not static, but constantly evolving, with no singular starting point. In this view, the Big Bang marks the limit of what we can currently observe, not the absolute origin of existence. Our equations may label it as time zero, but that could simply reflect the boundary of our knowledge. History, in this sense, does not start, it fades. The original question remains deeply unsettling. Did nothing exist before the Big Bang? Modern physics suggests that nothing is not an empty void. Even the vacuum of space seethes with quantum activity. Fields fluctuate, energy briefly appears and vanishes. Absolute nothingness may be an illusion, something our minds invent because it's easier than confronting the unknown. Perhaps the universe arose from a quantum process beyond space and time. Perhaps it rebounded from a previous cosmos. Perhaps time itself is part of a larger structure we don't yet grasp. Or perhaps the question itself breaks down at the edge of reality. The Big Bang theory remains one of the most successful scientific models ever created. It explains the expansion of space, the cosmic background radiation, and the large-scale structure of the universe with stunning precision. And yet, at its boundary, mystery remains. Science has not answered what came before the Big Bang, but it has shown us something equally profound. The universe is far stranger, deeper, and more subtle than our intuition allows. And as our instruments grow sharper and our theories bolder, we continue to push closer to the ultimate question. Not just how the universe began, but whether beginning is even the right word.